In this video, I'll demonstrate and describe structured exception handling in VB.NET. And basically an exception is anything that happens in your application that you don't want to happen or you didn't expect to happen. And computers are not like humans. They can't adapt to problems as easily as humans can. And so what happens when you don't handle an exception? Well, it's not a pretty sight. To demonstrate what happens when you don't use structured exception handling in your applications, I've created a small VB.NET console application that has one line of code. We create an instance of the file stream object, dimfs as new file stream. In the constructor, we pass in the name of the file and the operation we want to perform on that file. In this case, we're going to open a file named c:/lvs.txt. Now, as the comment above clearly says, this file does not exist on our hard drive, so this should throw an exception. So let's go ahead and build our application, and then we'll bring up the console window, type in VB_exception, the name of our app, and run it. And when we do, notice that a just-in-time debugger window pops up. Now, the most important aspect of this is that an exception, system.io.filenotfound exception, has occurred in our application, and it gives us some possible debuggers that we can use to walk through our application. If your users don't have the .NET framework or Visual Studio.NET, they probably won't see this if you were to distribute this application to them, but they get some really ugly error message. Obviously, this is something that we don't want to happen within our application. So go ahead and select No right now, and notice the error message that is placed onto the console window. Here we have an error message, unhandled exception, system IO, file not found exception. It gives a lot of the details, including the stack trace of the problem that was encountered. So it gives a lot of information, but you don't want your users to see this. You would like to be able to handle this gracefully. And that is why we have structured exception handling. So since we don't want our users to have to see those ugly error messages pop up whenever they're using our application, we need a way to handle the error and then deal with it appropriately. And that's what structured exception handling or structured error handling allows us to do. It's actually an organized approach to handling exceptions, and it promotes good coding practices. And we'll talk about some of the ways that it does that in just a moment. One of the ways it does that is that it allows you to check for the source of the problem, the actual problem, and deal with it appropriately. So based on the exception object that you get back, you will know exactly what the problem was. This is a lot different from perhaps what you did in VB6 and earlier and maybe other programming languages where there was a homegrown way of error handling. You may have go-to statements and labels and things of that nature. Structured error handling promotes one way to do it across all .NET languages or all .NET programmers. So this is something we really need to take advantage of as users of .NET. If you come from a Visual Basic background like I did, it might not be obvious at first some of the benefits of how .NET handles exceptions. But once you get the hang of it, you'll see that there are some huge benefits in the way that .NET handles exceptions. First of all, there's a concept of exception objects, and there are dozens, maybe even hundreds of different exception objects used within the .NET framework. And they can be very specific, like the one we saw with the file system error, where there wasn't a file found, so you have an actual object that gets instantiated and passed back to the calling application or method. And then there are some more general ones, like, for example, if an instance of an object is set to null and you were expecting there to be a real instance of that object. You might get something like the object reference not set or object reference null exception object passed back to your method or to your application. And so one of the neat things is that all of these exception objects are common across all .NET languages. So if you have different components, you can raise or throw an exception from one of your components into another component or into the calling application, and they know how to handle it. It's not something that's foreign or has to be custom coded for your company or for your particular applications, like maybe the way you did it back in VB6 and before that. And exception objects can be created and thrown across process and machine boundaries. There's really two concepts here. First of all, you can create an exception object and throw it yourself if you think that there is going to be a problem within your application. So maybe there's some things that are happening in your code and you detect that there's a problem, and you can create and throw your own exceptions and throw that to any calling object that that might be using your component or whatever the case is. And then also those objects can be used across other processes and across machine boundaries because they're just like any other .NET object that can be passed around in that manner. They can also be passed through web services. They can be deserialized into XML and then reserialized back into an object. So there's a lot of flexibility there. Also, and this is the neatest part, you can check for specific exception objects and react differently for each one. So in structured exception handling, you might have 5 or 6 different exceptions that you can check for on a given statement or two within your code, because there might be different things that come up. Like in our case, there was a file not found, but what if the file was corrupt or there was a write protection on it? And we're going to see some examples of that in just a moment. Also, since you have this type of exception handling, I guess one of the results is that you don't need return codes. I remember back in the VB6 days, in classic VB, you might return true or false for a method if it worked or if it didn't work, or you might return 1 if it was successful, or 2 if there was an error, or you might return the specific error number. I think that was pretty common across many of the applications that I've worked on. But when you're using structured exception handling, you don't need to do that. All you do is just raise the or throw the object back to the calling method or calling application, and then it should be able to handle any type of exception object that's passed back to it and react accordingly. The next point I kind of made a few moments ago. You can raise any exception that you want and throw it at any point in time. And then finally, you can also create your own custom exceptions. And this is an advanced concept, but it can be done. The danger here is that any applications that use your components have to have knowledge of this exception object that you create. And so there's some gotchas and things you got to watch out for whenever you're doing it. But we'll cover that in a future video. Now, we said that there were dozens, if not hundreds, of different exceptions in the .NET Framework class structure. However, all the exceptions derive from the exception class, the exception base class. And there's some common properties across all exceptions that you can be aware of and utilize whenever you write your applications. And they are, for example, the stack trace, which gives you all of the method calls that led up to that particular line of code that actually broke the application or was unexpected. And this allows you to get some context and understand better the exact spot where the exception happened within your code. Now, often you don't want to display this to the end user. By default, in ASP.NET applications, you're going to see that come up on that yellow default error screen unless you change the web.config to allow for that and show a custom error page. As we just saw a moment ago with the console application, it's going to display the stack trace method call chain, and you don't want your users to see that. But that's something that from a debugging perspective you can use and find out exactly where the problems are. There's the inner exception, which shows this has to do with whenever you have a chain of exception handling. For example, you might handle an exception that and it throws it back to a calling method that throws it to the calling method that throws it to the calling method. So you might have several different calls in the stack trace. And the inner exception will allow you to get to the original exception that occurred that set off this chain of exceptions that went up through the call hierarchy. The next is the actual message of the error, and finally the help link where you can find more help for that particular problem. Before we get into a source code example, there are 2 types of exceptions. First of all, there's the .NET runtime exceptions, things like execution engine exceptions, Stack Overflow, out of memory. These are the kinds of things that you can't handle and that you can't recover from. Then there are Application exceptions. These are things like invalid cast exception, where you try to convert something into a type that it can't be converted into, or argument null exception, or argument out of range, or a null reference, index out of range. There's literally dozens of these, and you have to handle these types of exceptions or else your application bombs, as we saw earlier. So here we've returned to our modest application that we created earlier in the video. And what we want to do is add some structured exception handling to it. And the way you do that in VB.NET is to wrap a try-catch statement around the lines of code that you want to test. So in this case, we'll do try and then end try, and then we'll add a catch statement. Space it out nicely. So let's explain what's going on here. When we put the try statement around some code, anything within the try statement will be attempted to be executed. If there's a problem with this line of code, then it will use the catch statement, if there's one appropriate. We'll get into that in just a moment. We'll use the catch statement to take some action. So in this case, the action we'll take is to write to the console, the error was and then we'll print out the error. So we've taken the exception object that's returned to us from the .NET Framework, and we'll take any messages, the default message from that error object, and print that out. So let's go ahead and save this and build our solution, and then let's attempt to run this. And you might say, okay, well, this looks exactly the same as before. It's not exactly the same as before. What we did was we added the text, the error was, and then we took the rest of the error and printed it out. So we were able to intercept the exception and then do something that we wanted to do with the exception. Now, we could completely ignore it. We didn't have to print it out to the screen, but we chose, for the sake of the example, to do just that. Okay, so that explains the basic concept of the try and the catch. But as you might expect, whenever you're dealing with a file system, there's a lot of things that can go wrong. So we want to check for specific types of exceptions. We just handled the general exception. In other words, no matter what the exception was, it would fall into this filter and we'd be able to capture it. But let's suppose we wanted to capture a different type of error. I've taken the liberty of copying and pasting some code here. What I've pasted in is the catch E as file not found exception. This is the specific exception that we encountered whenever we tried to execute this line of code. So we've gotten much more specific in our code about what to do if we were to encounter this specific type of exception, in which case we'll just write out, oops, wrong file. So let's go ahead and save this, build it again, and try to run it again. And notice this time that we caught that exception and intercepted it and printed out the text we wanted to print out. So let's go ahead and move on from here. Let's go ahead and change this line, and I'm going to paste in some more code in order to exercise some of the properties of the exception object. What we've done here is printed out the help link, the stack trace, and the message from the exception object if it were to fall into this final category of exceptions. Additionally, what I'll do is comment out this line of code and add a new line of code so that we can create a new type of exception. In this case, we're going to create a file stream object. We're going to pass in the file path for a file that does actually exist but is read-only on my hard drive, and this should be included with the source code that I provided for this lesson. And we're going to try to create a new file. Well, what's going to happen if we try to create a new file with the same name as a read-only file that already exists on our hard drive? Well, we're going to see some type of exception. There's something bad that's going to occur. So we'll probably ignore this file not found exception, and it will fall into the exception, the general exception object, in which case we'll print out some of the specific pieces of information about that exception. Let's go ahead and save this, build it again, And let's run it one more time. Okay, let's take a look at the results this time. Notice first of all that the help link was, and in this case there was no help link associated with this exception. But in some exceptions, and especially with your custom exceptions, you can include a help link with them. The next one is the stack trace, and this is what we've seen earlier, where we actually see all of the call hierarchy that occurred before we got to this exception within our code. It helps us to debug exactly the problems that were encountered before we got to this error that we're now working with. And then we have the actual message, which is the file already exists. The next thing that we'll illustrate, we'll actually take a couple steps here. What I'm going to do is cut and paste a line of code that will handle the exception that we just encountered, the IO exception. And we'll write out that file already exists. Let's go ahead and save that and build it just to make sure that we've captured the correct exception. Hit F3, run it, that file already exists. Very good. So now let's do this. I want to wrap the try-catch in another try-catch block. So we'll do this, try, notice everything indented over, and then we'll do catch, E as exception, and then N try. For some reason the N try didn't jump over, but everything else seemed to work just fine. And what we want to do is illustrate what happens whenever we attempt to handle exception and pass it back to another code block. And this could be a method within a component or a component to another component. The way we're going to illustrate this is by two try blocks within each other. So what we'll do here is paste in a throw statement. This allows us to pass an exception object back through the hierarchy so that it can be handled by another block of code. Again, that block of code could be another method, another component, whatever called this particular section of code. So in this case, we're going to throw a new IO exception object. That file already exists on the hard drive. We didn't have to throw an IO exception just because we caught an IO exception here. We can throw anything we want, including custom exceptions that we create ourselves. However, in this case, that's what we're going to throw, is an IO exception. When we throw an exception, it's going to pass that exception back up through the call chain, and so we're going to capture it right here. And what I'll do is paste in another line of code, console.write, the exception that was thrown was e.message. Let's go ahead and save this and build it and see how this works. All right. Notice in this case that we get the file already exists. Where did that come from? That came from our original catch line. The file already exists. Now the next step was to pass that exception object out of this chain of command back to its calling or up the hierarchy, in which case we'd expect to see the exception that was thrown was, and then the name of the message. So let's take a look at our console window, and indeed the exception that was thrown was the file already exists on the hard drive. So we want to take one last step, and that is to include a finally statement right here after all the catch statements. And a finally statement is used to clean up your application before it passes the thrown exception out to its hierarchical superior or up the call chain. Okay? So in this case, if we had a connection to the database or if we created some custom objects, we could set the references equal to null here and try to close down the database connections and do whatever we could to clean up the application's memory before passing the exception back up to the call chain. In this case, all we're going to simply do is write "that's all, folks." Now what would you expect to happen? In this case, we'd expect to see the file already exists print out to the screen. We'd expect a new exception to be thrown, but the real question is what happens first? Does our statement, the exception that was thrown occur first, or the finally statement? Well, if you guessed the finally statement, you guessed correctly. This will occur first, and then finally it will be passed off to its calling member. So let's go ahead and save this, build it, and run this just to make sure that it does what we anticipate. And let's take a look at the results. The file already exists, and that occurs right after the exception is caught. Then the exception is thrown, but before it's passed to the last line, the exception that was thrown was, the finally statement is triggered. That's all, folks. In closing, I want to give you a couple of practical tips about how to use try-catch blocks. First of all, you don't want to overuse them, especially if you get into a looping scenario where you're looping through an array or some type of collection. This can be a very costly operation if you do it 100 or 1,000 or 10,000 times within your app. You want to instead try to check for conditions before you actually just rely on the try-catch block. In other words, in the example that we had in the file stream, you could check for the existence of a file before you try to open it. You could check to see what the properties were. Is it read-only? Can I create a new one there? Before you actually just use the try-catch block all over the place. And then the other thing that I recommend, actually Microsoft recommends, is that you order your catch statements from the most specific exception to the least specific. Notice that we had our catch EAS exception at the very end, and all of the other types, like the IO exception, the file not found exception, those were all before it, because you want to filter through the most specific ones and then at the very end catch the most general exception. So that's how I would recommend using the try-catch blocks. In the next video we have a few comments about where to find the right exceptions for the situation that you're dealing with so that